आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanta Chandra Mohananobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics and its applications in various natural and social sciences. We welcome Professor Amartya Dutta from Indian Statistical Institute, Kolkata. He shares about his journey of research in today's episode.
I am Amartya Dutta from Indian Statistical Institute, Kolkata. I had done my PhD under Professor S.M. Bhattvadekar at the Tata Institute of Fundamental Research, which is famous all over the world as TIFR in Mumbai. And I was fortunate to be in the midst of a very strong algebra school at TIFR during late 80s and early 90s. Now, a fundamental area in mathematics in which Indians have excelled for the past 50 years is called affine algebraic geometry, which roughly speaking studies by algebraic techniques properties of geometric objects which are defined by solutions of polynomials.
Professor helps us understand the concept of polynomials.
So polynomials are as basic in algebra and geometry as numbers 1, 2, 3, etc. So as example of polynomials, the quadratic polynomial is taught in school, ax squared plus bx plus c. That is an example of polynomial. And let me tell you that Sriram Abhyankar, one of the pioneers and giants in this field of affine algebraic geometry, had started one of his mathematical poems with the lines, "Polynomials and power series, may they forever rule the world." So you can see the importance of polynomials and power series among the giants in these fields. Now, I'm happy to say that among many Indians, my guide himself, myself and my students have been contributing to this field. And I'll highlight one example of an outstanding achievement from India in this field of affine algebraic geometry. My former PhD student and now junior colleague at ISI, Neena Gupta, has turned the world of algebra and geometry by solving a very fundamental problem in this area. This problem is called Zariski cancellation problem, a version of which was stated by Oskar Zariski. Oskar Zariski is one of the founders of modern algebraic geometry, and he was incidentally the guide of Professor Sriram Abhyankar, whom I mentioned just now. So this problem was stated by Zariski 75 years ago. And you can understand the importance of cancellation property in basic mathematics. You use all the time that if A times C is B times C, you conclude that A equal to B, provided C is not 0. This is cancellation property of B. Similarly, you have cancellative property of spaces, and Zariski problem is about cancellation property of what are called affine spaces. It was known that cancellation property holds in 1 and 2 dimensions. In 1 dimension, it was done by Abhyankar, Ikin and Heinzer, and in 2 dimension, it was solved by Japanese mathematicians Bianishi, Fugi and Suji. Now, Nina showed that this cancellation property does not hold for higher dimensional spaces in situations which are described technically as positive characteristic. If all this sounds technical, note that national and international recognitions that she has been receiving. In 2019, she became the youngest ever mathematician in India to be awarded the Bhatnagar Prize, the highest scientific honor in India. Then Nina was awarded the DST IMU ICTP Ramanujan Prize in Mathematics from the International Center of Theoretical Physics, Italy last year. She was an invited speaker at the International Congress of Mathematicians last year in 2 sections, algebra as well as algebraic geometry. And an invitation to this International Congress of Mathematicians, or what is called ICM, is considered as an entry into the Hall of Fame of mathematics. And this year she has been awarded Ganit Ratna and the Young Scientist Award of the World Academy of Sciences. One thing I would like to emphasize is that all her education and all her research work has been done entirely in India. She has never been abroad for even for postdoctoral work or long visits. She has gone abroad only for attending conferences like the ICM. And this should be inspiring to those researchers who have to or who choose to work in India, that outstanding work, top-ranking work can be done in India itself. And no wonder last year the Honorable President of India awarded her the Nari Puraskar.
Professor explains about his field of work.
There have been researchers in Japan and Europe. The point is that so this affine algebraic geometry is a big area. There are several fundamental problems and people have been contributing in different ways. Now, but what happens is that when one particular problem remains open for too long, it tends to be treated as intractable, and then people cease to work on it. So Zariski cancellation problem, similarly, it was considered an important problem. People tried on it for some time, but after some time, they had given up. And what they tried to do is work around the problem, that is, work on something which may be relevant. And she is a mathematician who took the bull by the horn, as it were. And let me tell you that one top Japanese mathematician who had been visiting ISI Kolkata when Nina was doing her PhD, at that time Nina had tried to share her ideas with him on the Zariski cancellation problem, and he was absolutely shocked that such a youngster is thinking about the problem, because, you know, if something is intractable, then you end years and don't achieve anything, and then your career is doomed. So he was a well-wisher and he advised her that this is very difficult, you should not try it. But fortunately for the mathematical world, Nina had defied the advice and stunned it. And once when she was interviewed on Doordarshan, she recalled an advice that I had given her, which I have forgotten. But I came to know about my advice from her television interview that I had told her that you see that different mathematicians have different ways of thinking, and maybe that these great mathematicians, when they tried, their way of thinking and their tools didn't work for a certain problem, but you may be having a certain way of thinking which may work. So just because great predecessors could not do something does not mean that you will not be able to do that. Now, she says that this advice had helped her.
Sir focuses on the future directions to his present work.
Okay, there are two aspects to it. Her answer is negative, that is, a cancellation cannot be done. Now, had the answer been affirmative, like for example, the previous answers for 1 and 2 dimensions were affirmative, so people now can use that result to cancel left and right, whereas Nina's answer is that you cannot cancel, so it is a negative thing. But the point is that in the process, she has created an amazing wave of results which connects various fundamental problems and tools in the area. And this has killed various open problems, because from the theory, ready-made answers come out. So let me give an example that a few decades ago, there was an open problem on what is called Russell-Corrus threefold. Is it what is called isomorphic to affine space or not? And people spent a lot of time finding the answer, and eventually it was solved. But now from Nina's theory, it is a very easy consequence. So, I mean, things which will satisfy her conditions, one just gets ready-made answer. So, as I say, that she has actually killed many potential open problems.
We get to know about the significance of the current research to the academia.
So, let me give two answers to it. One thing is that her work is absolutely what is called in fundamental research. And as you know, that fundamental research has to be done for the progress of mathematics, which would eventually lead to applications. It could be 100 years later or 200 years later. Like Ramanujan's work was fundamental research 100 years ago, and now it is having applications. So it is the mathematical community which decides that which are the great works, fundamental works, which have to be pursued in the interest of mathematics, and this is definitely identified as one important problem. So this is the technical answer. And from the social point of view, the fact that Nina has come from, very completely from an Indian background, educated in a Indian school and college, here in Bethune College in Kolkata, and did all her research in India. This should be inspiring, and not only that, there is this defeatist mentality that first of all Indians do not do worthwhile research, and if they do, if it is by going abroad. Now, India, don't get me wrong, certainly Indians should go abroad and do research if they feel that that would be the best way of contributing to the kind of problems they are involved in. But if somebody chooses to remain in India or has to remain in India, there is no reason to feel defeatist. So we have examples from the past, from the recent past of outstanding achievements. And here right now in the 21st century, in the last decade and this decade, you have Nina, who has practically never been abroad and achieving top-ranking work.
We are immensely grateful to Professor for his excellent deliberations.